Okay, well, I'll start with introductions, and then if anyone's taking a little bit longer to come in, that's fine. It'll take us a couple minutes. So good morning, or good afternoon, I guess. Sorry, good afternoon. My name is Janelle Springer. I'm based out of the Calgary office, and I'm excited today to introduce our two speakers. First up, we'll have Rachel Grande. She's our technical sales manager, and as of today, she is based out of the Houston office. Many of you may know her from the Denver office, but she just moved down to Houston. So Rachel's going to be doing two of our little demos today, and then Kory Wiley is one of our technical sales analysts, and he is also based out of the Houston office. So if you have done a lightning round presentation with us before, you know what to expect. But if not, what this is, we do it just once in a while, and it's just kind of fun. It's sort of like TikTok style, if you will, is what we like to call it around here. And it's a workflow of something that's really quick and easy to do. So something that you could do without anything extra. It takes maybe 10-15 minutes. That's just something different to what you're usually using StarSteer for. So guys, did I miss anything before we get going? All right. Well, without further ado, let's get going. If you have any questions, please feel free to put it in the Q&A or the chat. I'll be monitoring it here today. And otherwise, we will get going here. So first up, Rachel is going to be doing a presentation on completion visuals, specifically, oh, sorry, I did a bad job of copying and pasting there, but it is, this is for the Eagleford. Rachel's going to be showing it in the Eagleford, but please know, obviously, it can be used in any play that you have available to you. Like I said, Rachel is the technical sales manager, and if you have any questions, she would love to hear from you.
All right, so today we're going to talk about completions. So this is a relatively new feature that we have. It was introduced in StarSteer in 2025.1, so around the May timeframe is when this came out. Of course, we've had the ability to visualize completions data in the past. We had a Python script where you could input all of your different attributes, all of your different data, and then you run the script, and it would essentially take those attributes and it would output them as a curve data. And this was a really great way to visualize completions data. But since then, we've evolved into creating the completions, excuse me, attributes themselves. So it's very, very new. So there's not a lot of little bells and whistles, but it is very functional. So we'll just kind of get into the loading the data, how to visualize the data, and some analytics you can do with it. So you just want to go to the well that you want to have completion data for. So it's important to recognize that when you're talking about completion data, there's several different types of completion data. You have kind of from the well base, so what is your total proppant, what is your total fluid? You have your stage base, which would be what attributes you have on each different stage, and then you would have your time-based data. Right now, ROGII can really only handle the first two, being like well-based data and then stage-based data. But in StarSteer specifically, it's going to be the stage-based data. So you just want to import the attributes that you have from a spreadsheet here. So if you go to completions, then you can just toggle to the spreadsheet that you want to assign it for. Then toggle to the spreadsheet that you want to look at. So right now you can see I have 3 different attributes labeled. This is going to be the top MD, base MD, and stage number. These are the 3 attributes that you're going to need to import the data. It's required. Interestingly enough, just for those that are familiar with completions, you're always going to frac from the toe, and then you're going to move your way back to the heel. But the top and the base and stage, the depths are going to move in the measure depth direction. So just know that the 2 data sets are kind of moving in opposite directions. If you do it wrong, it's okay. One of the things that this program does is it automatically creates a attribute in terms of length. So if you do it in the wrong order, you're going to get a little yellow triangle telling you, hey, the base should be the top and the top should be the base. But past that, I have a couple of additional attributes here. And you can see that we have those 3 required ones. They're automatically going to be dropped down, but the program is smart enough to recognize the title up here. So it's just going to go to hours ellipsed, average pressure, average rate, and frac rate. And then you're going to import that from there. So once I've imported that, you're going to see I now have a completions tab within my object tray. So if I turn that on, you're going to see that everything sort of populates up here. I'm just going to move down, and I'm going to move all of these down here. Again, apologies, I'm dealing with a mouse pad. Interestingly enough, we have the length up here. I can always change this to extend up, so you can now see the stages as well, because they're going to automatically default to the width of the stage itself. And I'm just going to go into this length here, and I'm going to change it to be the same color as the stages. So you can see the two different stages. Of course, you can always pull the stages down here. And if I zoom in, you can see that there's stages and there's going to be spaces between the stage. What makes this different from what we had previously, which would look very similar here, which you would have different attributes, is this is now extremely dynamic. So instead of having these static widths of these bars that show up, I can now turn on and off different attributes, and it's going to automatically scale to match the width of the stage itself. Additionally, I'm able to take these attributes and put them on the well itself. Just do a couple. Let's do average rate as well. And then I'm just going to zoom in here and just pan up. So you can see we have these three attributes right here. What's interesting in 25.2 is now you can change the orientation. So if I want my average rate to be below the curve, I can do that. So it will automatically, again, scale to be the same width. Additionally, if I want to look at my frac gradient here, and I want to maybe extend the width, I can also change it so it's a little bit more pronounced without having to change the scales in the horizontal tract. So it's a really simple, easy way to look at your completions data. There's no limit on number of attributes that you have. I will say that if you are going to bring in attributes, you want to condense it down to one spreadsheet. Right now, it does not do a very good job of merging the two spreadsheets together. So just a little bit of organization ahead of import, you can get all the attributes you want in one import. But moving on to analytics here. So I'm going to jump over to a map view here. Here we have 4 wells. I'm only going to be looking at 3 of them here. And let me turn off that 4th well. So what we're looking at here is we're looking at 3 wells that have been fracked on the stage, same path. And what we're going to be looking at is SH max and potentially what regional stresses are doing in the field. For those who don't know what SH max is, it stands for stress horizontal maximum. If you think of a stress regime, you have a vertical stress regime and 2 horizontal stress regimes in that little cube. There's a lot of science behind it. Just know that if you are in a tensional or normally faulted basin, the SH max is going to be the orientation at which the faults are going to propagate, or fractures are going to propagate. So here you can see we have a couple of faults in the area. It's roughly 44 degrees. So what I've done is I've gone and I've used my measuring tool here, and I've sort of measured out between these 3 at roughly 44 degrees azimuth through there. And I've created a top set. So I'm just going to turn that top set on just to show you. So here you can see I have different tops throughout here. So what I'm going to do in the correlation panel is now that I have these on, I do want to look at them. And one of the things to note in the completions data set itself is probably one of the very few times that we sort of recommend people looking at it at measured depth. And that's because the data is going to be spread out a little bit more evenly. So here you can see I have a whole bunch of data. Let me just apply this to all. Let's see here, 13, let's get that average in there, average pressure and frac rating. So here we have similar attributes turned on between the different wells, and then you can see my SH max of 44 degrees. So what's unique about what we can do is we can take this top set and we can hover on it. See if I can flatten on this instead. Sorry, it's a little finicky. So now you can start doing some analytics that's based on the stresses that you're seeing in the area. So you can see there, especially if you look at the frac rating here between 12H and 14H, there does seem to be some correlation in terms of the shape. You can see it a little bit in the 13H. I will tell you that the 13H is drilled in a different horizon than the other two, but you can start doing some analytics in terms of what is going on in the XY direction. But we also know that it's not just X and Y. We also need to look at the Z direction as well. So if I go to my interpretations here and I turn on my lower Eagleford top horizon, let's see if I can bring that over there. So here we have my interpreted horizon of the lower Eagleford. Switching over from measured depth to TVT. I'm then going to zoom in and flatten on this curve, this line. And then zoom in here. So like I said, the two outermost wells are going to be drilled in opposite different horizons. You can see the 13H is going to be drilled slightly higher. But now you can start looking at potentially different attributes that are going on within the stratigraphic column itself. In addition to this analytics, I do want to toggle over to our Solo data factory real quick because I talked earlier about we have well-based data and then we have stage-based data. Our Solo data factory, which is going to be in our advanced data manager, will also handle that well-specific data. So if I take my lasso tool and I have my Solo data factory button turned on, which is blue, and I can just highlight it, give it a second, you're going to see all of a sudden I have all of these wells that have populated within the gun barrel view. And I can change that to display my, let's say, total proppant. And then I want the color to be on total fluid. Oh, it is already on total fluid. Let's do something different. Let's do 12-month oil production. So now you can start doing analytics of the gun barrel view based on different completions parameters and production values. Those who are not familiar with Solo Data Factory, this is something that is relatively new to us. We've gone through and we are actively going through different states within the United States, as well as I believe we already have Alberta. But we've scraped all of the public regulatory data and we've integrated this in. So these wells that I've just highlighted, and you can see it on the left-hand side in yellow, aren't actually part of my project itself. So I can start doing some offset operator analytics without having to bring them into my project. If I do want to bring them into my project, I can always go up here and I can import the 28 wells that I've selected. And with that, that is the lightning round of completions.
That was really good to see the whole process there, Rachel. That's the first time I'd seen it. Thank you. Does anyone have any questions for Rachel? Casey has one. It's in the chat there, Rachel. Let me read it out. It's just loading here. What about the fracture orientations and angles represented in the well stage visualization?
You're talking about like penny fractures, those penny diagrams?
The follow-up was the fracture direction.
So we do have a Python script in here. We have 2 Python scripts in the templates under completions. We do have the stage ellipses where you are able to put the fracture directions up, down, left, right, if you have a spreadsheet. I don't have a spreadsheet that's kind of prepped to show you, but this is a good way for you to create those sort of penny fracts that you might be familiar with if you were using forecast.
Casey, hopefully that answered your question. Thanks, Rachel. Any other questions? Casey says thank you. Okay, well, Rachel's going to be coming back here. So if you think of anything, like she has another presentation in a couple minutes here. So if you think of anything in the meantime, you can ask it when she's back. We're going to switch over to Kory. So Kory is going to be presenting from about cuttings today and how we can use cuttings within StarSteer, which is obviously a very unique application. And there's Kory's information if you want to follow up with him. All right, Kory, I'll pass it over.
All right. Yeah, so thanks, Janelle. My name is Kory. I'm a technical analyst here at ROGII. Before I started geosteering and working with ROGII, I also worked in the mudlogging industry, mudlogging out in the Permian Basin. And that's what I want to talk a little bit about today. And so one of the things when I was mudlogging that my supervisor told me was that the mudlogger is basically the eyes and the ears of the geologist on the rig site, right? Because the geologist is usually back in the office. They're not on the rig. They don't really know what's going on necessarily on the rig. And the mudlogger, they're kind of not just collecting like lithology data like we could think of. They're also collecting like gas data. They can be collecting XRD, XRF data. They're collecting data about the mud weights from the mud engineer. They're looking at some drilling data like weight on bit, RPMs, all that kind of data. They're collecting that information. They're compiling it on what we call a mud log, and they are then giving that information to the geologist. So it's kind of not only is it, again, like this lithology data, but it includes a lot more information that the geologist is relevant to operations. And one kind of major limitation of mudlogging that really holds it back from being more widely implemented, at least here in the United States, one problem we often see is the mudlog is traditionally only sent out twice a day. It's typically sent in the morning and then again at night. And so there can be a 12-hour period where the geologist has no idea of what's going on necessarily on the rig. They don't know what the cuttings are looking like, what they're drilling through, what the lithology is. And so one thing we've kind of worked, we work a lot with our third parties here at ROGII to try to improve functionality for getting this lithology data from the rig to the geologist as quickly as possible. We've worked through a couple different solutions, and today I want to present one in our software called TLog. So if you're not familiar with TLog is a mudlogging software that became part of ROGII's kind of like software suite here maybe about a year ago. And since we acquired TLog, there's been quite a few changes in how we've implemented it into the solo cloud environment. So that's kind of what I want to talk about today. If you've never seen TLog before, here's an example of a TLog mudlog. And you can see it's very, very flexible. We have some gamma ray RP data. In this case, this is a bunch of mass spec data that we've implemented. We can also use XRD, XRF, really anything that's a log we can display here in TLog. You can see we have some lithology descriptions over here on the right, as well as some images we can look at. And you can see over here we have our mud weights and our viscosity. This is the information coming from the mud engineer. We can display here in TLog. We can also display information about surveys or the drilling variables. We can make really any kind of note we want here in TLog. And the TLog, the wells can be displayed either vertically like we're seeing here, or we can also switch to display the mud logs horizontally, which so when you're in the lateral portion of the well, some people prefer this view. And so here you can see we're plotting the survey TVD, so you can kind of see the well bore as we land the curve and then get into the lateral section of the well. So something I hear often about TLog is what I was trained on when I was mudlogging about 8 years ago now. One thing that I always hear is that TLog is incredibly user-friendly. It's one of the easiest mudlogging softwares to use, but it's also like super customizable. You can come in here and kind of select whatever tracks you want and very easily customize the mudlog depending on what kind of data you're representing. And so one thing what I want to focus on today is how we have now integrated this TLog software into our Solo Cloud environment. So I'm going to go ahead and close out of this mudlog, and I'll show you how we can pull up our mudlog data here. So when you first open TLog, one second, looks like I might need to log in real quick. All right, 1 second. All right, so when we first log into TLog, it looks something like this. So this is the kind of the window that pops up. We can see our recent files. You can see here we can also open cloud wells or local projects that we have on our computer. Well, if we open this cloud well right here, what's going to come up is this window right here. And now what we can see here, this is a list of my Solo projects. So the idea is the geologist can create the well or the project in Solo. And then the mudlogger can log into TLog and they are able to see those Solo projects that the geologist has created. So this is one of my global projects that I have here inside of StarSteer, and I can easily connect, and here are my Solo wells. So this symbol right here indicates that we have a current mudlog that has been created for these Solo wells. So again, these wells here, we'll go ahead and take a look at this demo well 12H right now. For this demo, you can see I've already created a mudlog, so we'll go ahead and open it. And now this TLog well that I'm looking at right here, this demo well 12H, over here in my background, you can see we have the exact same well open in StarSteer, this demo well 12H. So this well exists in Solo not only as the geosteering well, but also as this mudlog well that the mudlogger has created. Okay, now let's say I'm the mudlogger. Let's say Rachel's the geosteerer or the geologist. And she wants my my mass spec data. She needs it to kind of judge if they're in the target zone or not. So Rachel also wants my sample descriptions and my mudlog that I've created right here. Well, you can see right here, I know I'm connected to the correct well. I am connected to this demo well 12H in StarSteer. All I have to do is hit this push button right here, and it will push this mudlog data straight to StarSteer. So now if I go into StarSteer again, you can see I now have this mudlog that was created in TLog and was pushed to StarSteer. I also have this TLog folder, and you can see all these logs here. These are all those same mass spec logs that we were looking at in TLog are now visible here in StarSteer. And so, and it's really easy. Let's say I'm the mudlogger. If whenever they update the interpretation, let's say I've changed the mudlog. Let me go to the very bottom here. Let's go ahead and just make a change to the interpretation. And now we'll go ahead and hit the push button here. And now when I do that, when we come back to StarSteer, it might take a few minutes because we have quite a few logs in this project, but you'll see there it just happened. The mudlog updated based on this new data that we generated in TLog. So again, it's that problem where the geologist only gets the mudlog data infrequently. Now all the mudlogger needs to do is hit that button, and it will instantly push the mudlog data and the curves that exist in TLog straight into StarSteer. Something I don't have displaying right now, it also pushes the sample descriptions. So I believe I have those in this project. Let me take a look. Right here we go. So the sample descriptions that were generated in TLog also push over to StarSteer as well, and they will be indexed on the correct depth based on where they existed in TLog. So we can also click on the spreadsheet, and we can see all those sample descriptions that the mudlogger was generating as well. Now, once this data is in StarSteer, there's a lot we can do with it. For example, we can use correlation panels to kind of compare our mass spec data to other wells. You can see I have one here. So this mass spec data coming from TLog, we're comparing it to some of the other offset wells that we have on this pad. We can also, for example, display XRD data. So this is a request I probably received the most, is where mudloggers want to instantly push XRD data from the rig to the geologist. Well, we can easily do that after you load the XRD data into TLog, you can push it to StarSteer, and then you can display that XRD data. And you can also, over here on the right, this is a percent lithology or percent XRD curve. So these can be generated in TLog and pushed to StarSteer as well, like I showed you here with the percent lithology curve. Yeah, and so that the idea behind this new acquisition of an integration of TLog is we've now fully integrated TLog into the Solar Cloud environment. So any well that is created in TLog can be connected to any well in StarSteer, and data can be pushed from TLog to StarSteer. And in the near future, we're also going to be able to push it backwards. So data can go from StarSteer to TLog. That addition will be coming sometime in the next few months. And then finally, to wrap it up, one thing I did not mention is these mudlogs also exist in the cloud, similar to StarSteer. So as I'm working on this mudlog, Rachel could also log into TLog, and she could open up this well, and she could see the changes as I'm making them in real time. So this TLog also is very similar to StarSteer Solo Cloud. We can do live logging together using TLog. Yeah, so that's all I wanted to show today. So to kind of summarize, we talked about how TLog now is fully integrated in our Solo Cloud environment. So we can kind of push data back and forth between TLog and StarSteer to kind of solve that problem where mudlog data is not getting to the geologist fast enough. Now we can push it in real time very, very quickly. Okay, yeah, does anybody have any questions about TLog or this kind of integration we talked about today?
Gonna let him off the hook easy?
Yeah, that's good with me.
Okay, if you are interested in TLog, if you haven't heard already, it's free of charge, at least until the end of 2026. So you're more than welcome to pick it up, whether you're working at an operator, working as a mudlogger or a well site consultant, you're more than welcome to get your copy. Okay, perfect. So our final presentation today, Rachel's back again, and she's going to be showing us net pay zones. Oh, maybe we did get, all right, before I introduce Rachel, Kory, we do have a question for you. Are you sometimes using the gas ratios to determine contacts while steering?
Yeah, that's kind of that can be the idea. So you could bring in, for example, if you bring in like your ratios, like your wetness and balance ratios that are created in TLog, or you could, for example, if you're using like the XRD data to look at the ratios of different elements, you can kind of use that information to judge formation contacts, or to a lot of times that information, like the XRD data, is used in the completions process for kind of judging brittleness. So there's kind of a lot of different applications for the mass spec data and for the like any kind of XRD data that you're bringing in. And I didn't mention this in the talk, but you can do log calculations in TLog. So if you wanted to do like ratios of different gas curves, you can very easily do that, do the custom calculations in TLog.
Good question. Thank you. Okay. Yeah, please keep the questions coming. We're going to get started on Rachel's second one here, which is on net pay zones. And it'll be a case study from the Dakota Sands in the Williston Basin.
Okay, so here we're going to look at an area. This area is in Burke County, North Dakota. And just for this conversation, pretend I am a geologist that is looking to create or drill a well specifically for disposal. So I'm looking for different net pay zones of sand bodies within the Dakota group, which is a whole bunch of formations, specifically the Inyankara. So I have a whole bunch of data, and I kind of want to determine like where is the highest chance that I'm going to drill a well with the thickest amount of sand. So if I go into my correlation panel here, we're going to define sand by a gamma value here. So we can and always have been able to take a certain cutoff and apply that to a curve. So here you can see all the fills in data that I have, is based on, I believe, 50 or 55 API. And so you can start getting a visualization of where there are sand bodies and where there aren't sand bodies. But we can take that one step further. Last year, we introduced zones to StarSteer, and it's one of our more powerful attributes that I don't think gets enough attention. And creating zones is really easy, but in complete transparency, it's not the most obvious workflow. So to create a zone, you want to go to a top set, and here I only have one top set. And zones are going to be specific to the top set itself, because what it's going to do is it's going to automatically create a zone from formation A to formation B to formation C, so on and so forth. Of course, you can always customize what the zones are going to do, but just for the purposes of this talk, I'm just going to show you really quickly how to go through that. So in the group tree, if you go to a top set and you zoom all the way to the bottom here, you have zones that are going to populate. If you right click on the zones, you can say add all zones, and it's going to do that sequential order that I just went through. There's a lot of formations in here, so I'm not going to make it chug out. I can show you right now. It's created a whole bunch of different formations in here, zones based on these formations. But what I want to look at specifically is I want to create a new attribute within these zones. So if I click on zones itself, and once my zones are created, what I can do is I can say log attribute. So in this case, like I said, I'm looking for total sand bodies based on the API cutoff. What I can do is I can do net thickness, and then I can tell it that I want to go and use my gamma curve, and that I want to apply a filter. So here's the filter where I want cutoffs. So it's going to be, I want my filter to be from 0 to 55 API. And once I've created that, I can just hit create attribute. And it's going to go through all of my zones, all of my wells, and it's going to create this cutoff attribute for the entire program or project that we have. Once it's done, I'm just going to hit close. And now if I zoom down here on my zone attributes, you can see I have measure depth thickness, TBD thickness. This is going to be similar to what I talked about in completions. This is going to be something that is just automatically calculated. Enough, I can't actually delete this. If I were to right click on the zones, you can see I can delete them. So these measure depth and TBD thicknesses are going to automatically be calculated. If I turn that on here, now you're going to see that I have these bars that show up. I can always right click over here, add a new track, and then move this over here. And then I can display the values themselves. So now you can kind of get a sense of what that thickness is on each of these wells. What I can do is, now that I have these, I can always visualize them on the map. So I can go back to my map view here, and I can, give me one second. So now that I've calculated them in the correlation panel, I want to visualize these in maps. So what I can do is I can go over to my mapping mode here in my maps. And what you'll see is we have added an additional button down here. So we have structure, and then if you drop down here, you have properties. So the properties are going to utilize your zones. Your structure is obviously going to be something that utilizes structure. There's a couple of primary differences between that. The biggest one is in this algorithm, the auto. If you are in structure, it's going to automatically go to convergence interpolation. So it's going to take all of your data points and it's going to recognize a certain trend. So if things are generally dipping in the northwest direction up and then dipping down in the southeast direction, regardless of you have points or not, it's going to take that trend and continue it beyond. Your property mapping, it will default to ABAOS, which I have looked up 1,000 times and I still can't remember off the top of my head. Maybe Kory can help me. But what that's going to do is it's going to bookend your data. So regardless of what's going on in trends, if you have 100 points and all of the points are between 0 and 53, it doesn't matter what the trend is going to do. It's going to make sure that those data points do not exceed the bookends that are defined within your data set. The other big change when I switch over to property is I want you to guys pay attention right here. And what that's going to do is I go to property, it's actually going to have an attribute. So here's where you're going to utilize the zone. So I'm going to scroll up here to my Swift, in your car Swift zone. And I'm just going to take that zone and I'm going to dump it in here. And once I define the zone that I want to map, it's going to unlock that attribute. So again, we have those two measure depth and TBD thicknesses, but we also have that net thickness of 0 to 55. So I'm just going to click that, and everything else looks good. And I'm just going to really quickly map this, create new grid. And then I'm going to turn that on. So what you're going to see is we have a lot of data points in here, but it's kind of a mess in terms of structure. You wouldn't think that things are deposited in this way. There's definitely going to be some sort of trend. Now we do have various tips and tricks to sort of manipulate the data themselves. One of the things that we can do is we can add an anchor point. So I can click and add that anchor point there. And then I can just click and then I can define what I think it is, right? Another feature, let me actually turn this on here. So here we can see the values. So I can input what I want to do in that way. But what we kind of found is geologists, and I am definitely guilty of this, prefer to kind of do some hand contouring. Now, we don't necessarily have the hand contouring capability within StarSteer in terms of it's a hand contouring feature. What we do have is we do have the ability to create polygons and sort of fake the hand contouring. So if I go into my polygons here, I'm just going to click a new polygon. And we'll just say hand contour. And so what's really important here is if you click it on, you click on the Z value before you start. Then when you go in, you can define what that value is. And then you can start creating a new polyline. So now you can sort of start manipulating the data so you get that line. The program, because this is sort of breaking the program on what the polygons were meant to do, just note that it's not going to take into consideration these lines between the nodes. So if you have something that's really complex, we recommend utilizing more and more or closer together nodes. But you can also add multiple nodes in here. So I can just do new polyline, and then let's say this is 350. So they're not necessarily tied to a single depth. This is a really quick way to sort of utilize the nodes. You don't need to see me do this for the entire demonstration. I actually have hand contours that I've already gone through and I've created. So going back to the mapping mode, I'm just going to take that hand contour polygon that I've created. I'm going to add that in there. I'm going to remove my anchors. And then I'm just going to update this grid with that polygon layered in. So what you're seeing is we're going to have much more of that depositional trend moving from the southwest to the northeast. And if you remember my initial question, which is I'm trying to drill a disposal well with thicker sands, where should I drill my well? And what you can clearly see is I should be focusing here in the southwest and not the northeast. There's much more to zones than just this, but this is a good demonstration of what you can do with zones and different attributes that you want to calculate. I hope you guys find this helpful. Thank you.
Thanks, Rachel. I know that's a feature that hasn't, that's still new to a lot of folks, so hopefully you learned something from that. Any questions for Rachel or Kory about any of the presentations today?
I did have, I guess, that follow-up question for Rachel, because I know we've talked about this in the past, but that project you were just showing, I know most of the wells are oriented north-south, but some of them are oriented east-west. I know we had talked about I believe the principal stress direction in that area being east-west. Do you know why some of the wells are oriented perpendicular to each other? Is it just due to the acreage in that region?
Principal stress does move around quite a bit. Many times you want to be perpendicular to maximum principal stress, but often leases will make you drill a certain way. You don't want to be aligned with principal stress. In that area, it's around 45 degrees. So even if you're 45 degrees off of that, you're still kind of at an oblique angle. If they were drilling parallel with them, that would be detrimental. But even if you're 45 degrees versus 90 degrees, you're still getting that fractures propagating away from the wellbore itself.
Yeah, thanks for asking. There was a question in the chat about it. I said, unfortunately, we don't know for sure because they're not our wells, but those are all good thoughts. Okay, well, if there's no other questions, we'll leave it at that. And just a reminder, we have 3 to 4 of these webinars every single month. If you're not on the mailing list, I'm sure you are. That's probably how you found out. But if you're not, please reach out to us and we'll make sure you're on the mailing list as well. If you have any ideas or if there's anything that you want us to show, please let us know. We're always looking for ideas of what to show you. Otherwise, have a good rest of your day.